And we're live. Welcome back for another virtual IoT meetup. Today we have two speakers. I think it's been a while since that's been the case. We have Kai from Bosch Software Innovations, joined with Paolo from Red Hat. And today we're going to talk about Eclipse Hono, which is an Eclipse IoT open source project. So as always, please make sure to use the YouTube channel or Twitter to ask your questions along the way. We certainly don't want to wait until the very end to get your questions. Remember that this is live, although you might be watching the replay. It's probably better to ask your questions now. And yeah, without further ado, I will let Paolo and Kai introduce themselves and get started with their presentations.
So, hi, and welcome to this meetup on the Eclipse Hono. Let me just share the screen just for introducing me and Kai. So, my name is Paolo Paterno. I'm from Italy and work for Red Hat as a senior software engineer on the messaging and the IoT team. And I am lead and committer for some different projects in Eclipse Foundation, like, for example, Ono, of course, then Paho and Vertex. I like to blog, speech, and something like that about messaging, IoT, and embedded device.
Okay, hi from me as well. My name is Kai Hudalla. I work at Bosch Software Innovations in Germany. We're basically doing foundational technology for enabling IoT applications in arbitrary application domains. And I'm also quite involved in several IoT projects at Eclipse. In particular, I'm the project lead for Hono for Californium. And I'm also a committer on Leshan, which is the lightweight M2M stack that we have. Paolo, why don't you take it from here?
Okay, so it's the agenda that we will follow during this meetup. Just some information around the Internet of Things, the protocols, the communication pattern, and something like that. And then we'll introduce the project, so Eclipse Hono, the goals, the features, the architecture, and we'll have some demo time for that, showing how actually Hono works and how we can use that for interacting with devices. So, starting speaking about IoT, what makes an IoT platform today? We can consider Internet of Things something like a specific use case in the messaging area. So we can say that the core piece of an IoT platform is the messaging infrastructure, because we have to exchange messages, in this case, between devices and cloud services. Then around this messaging infrastructure, there are some IoT core services. So some services that are focused on the IoT, so interacting with the devices. For example, one of the main pieces can be the device connectivity service that we will see in a bit is provided by Eclipse Hono. So the service which is used by all the device for connecting to the IoT platform and using, for example, different protocols and so on. There are other services, for example, like the device registration service, because the IoT platform needs to be aware of the device that can connect to it for allowing them to connect. Then authentication and authorization, of course. And then, for example, device provisioning and or software updating for devices. So the messaging infrastructure plus all these core services made an IoT platform. And on the other side, on the backend side, we can see we have all the other applications for monitoring, for real-time streaming, for machine learning. So all kind of business application that we can use for getting data from the IoT core services, interacting with devices and getting some value from this data. In the IoT space, another problem is the different communication patterns that we have in such IoT platform between the cloud and devices. So we have, for example, the telemetry pattern where the data flow in a unidirectional way from the device to the cloud. The inquiry where the device is able to ask some information to the cloud, getting the reply from there and the related data, of course. Then we have the commands and control pattern where from a cloud service, we are able to send a command to a device in order to have such device execute some operation in the field, in the environment, and then replies to the cloud with the result of such command. And finally, the notification pattern where the cloud is able to send a unidirectional flow of information from to the devices without waiting for replies from them. So the two big patterns that we can consider in the IoT space are telemetry and command and control. We can see in this picture that the huge data traffic comes from telemetry, because on the left side we have a lot of devices that can send a huge quantity of data to the cloud. And this kind of communication should be optimized in terms of throughput, scaling with the number of the messages. So the number of the data and the messages that bring data that comes from things on the left side. Then the command and control, that is a bidirectional communication between things and cloud, is optimized for reliability, because we need that, for example, a command sent from the cloud to a device will get to device even if it's not online in that moment, but the device could get this command later when we'll come back online and executing it. So we need reliability and scaling out with the number of devices that we have on the other side, on the things side.
Before you go on, Paolo, let me add one little thing here. Another big difference between telemetry and command and control is that it is usually not a problem if you lose some of the telemetry messages on the way, if they do not reach their final destination or consumer. Because, for example, if you imagine a temperature sensor sending the current temperature reading, it does not really matter if you only get the next temperature reading after 5 seconds instead of after 2 seconds, and you lose one in between, because that will usually not be very different from the first and the third one. So that is a big difference between telemetry and command and control, where you usually do not want to miss out on any message, or make sure that all of the commands that you send to the things actually get there, or are delivered and you get the response. And by the way, if you have any questions, you can enter them in the chat, and we try to take some time in between and figure out whether there are some questions that we should address. Okay, sorry for interrupting.
There is a question. What do you use for the cloud?
We will see that the Eclipse Hono project can be deployed in different ways, but it's something that we will see later. You can deploy this project just on premise, so in service in a server that you have in your own farm, or you can deploy it on Azure, on Amazon, or something like that. So this is a big difference that we will show in a few about using something like Eclipse Hono or some IoT services that are provided in the cloud by other companies, for example, like Microsoft, Amazon, IBM, and so on.
All right.
Okay, so as I said, if we consider the IoT as a specific use case as messaging, we can say that the IoT communication patterns that we saw before can be mapped or on the related messaging patterns. So for example, the telemetry and notification that are unidirectional flow of data from device or from the cloud are just something like the publish subscribe from messaging. So there is a client that is publishing information, and one or more clients that subscribes for receiving such information. On the other side, for example, the command and inquiries are about the request-response pattern from messaging, because a client sends a request in the command case, a command, for example, from the cloud to device, and it will expect to receive a reply, a response for that command. So we can map the IoT communication pattern to the messaging pattern. As we'll see, there are a lot of different IoT protocols in the field, and all these different protocols implement or provide support for such patterns in different ways. So, for example, the MQTT is most focused on publish, subscribe, but you can have a request response building something like a more level upper the MQTT protocol level. You have the HTTP, which supports request response natively, or for example, ANQP 1.0 that supports both, even the publish subscribe that request response. Regarding protocols, we know it's important to have interoperability. This picture is funny because the starting situation is having 14 competing standards. So people speak about that and then decides to have another protocol for rule all then all, right? But then the final situation is just having one more protocols. So the problem is not find to a protocol that can be used instead of the all the other protocols that we already have today, but it's about supporting more different protocols. So for example, on the right side of the slide, you can see some of the well-known protocols that can be used in the IoT space. So it's important for an IoT platform supporting more than one protocol for different use cases. Now, just related to the question that I answered before, what are the existing offerings that we have today for IoT solution in the cloud? We have some from Microsoft Azure, from Amazon, from Google, from IBM. With all the related services just focused on IoT app, so for handling on IoT, like the IoT app from Azure. So they provide the service for ingesting data, messaging from devices, for handling device registration, and so on. What could be the problem with such offering? First of all, they are not open source. And there is a big deal in terms of where I want to deploy my IoT solution. So for example, I can decide to start with a few devices and then having my solution grows to 100 or 1,000 devices. So I can move, for example, with this offering, I'm starting from the cloud. I can start from installing my solution on-premise and then moving from on-premise to the cloud. So it's even difficult, for example, if I decided to start using a IoT hub-based solution, then for some reason I decide to move from Azure IoT Hub to Amazon IoT, it's quite difficult to move my solution from one cloud to another. So I have to change maybe a lot of things in the application side, on cloud, or on the client side, and so on. So it could be more complex to have this kind of solution moved from one cloud to another, or for example, from on-premise to the cloud.
I can add another aspect here from a Bosch perspective. For example, we originally thought about whether we want to use a standard offering from one of the commercial vendors, connecting the Bosch devices to such a cloud offering. But this kind of represents a vendor lock-in. So while this may work quite well out of the box and work today very well, it might not if, for example, the vendor decides that they want to increase the pricing level by 10%, killing our business model. So for us, it is very important to be able to actually have this touch point under our own control and do whatever we want with it. So that was one of the reasons why we started to create the Eclipse Hono project. And for us, it was very important that we do that in a community, in the IoT working group, because we think that this is such a foundational technology that it should not be developed by a single company or in a proprietary way, because it should be flexible enough to support arbitrary use cases. And that is why we chose to do that in the IoT working group. We've started together with some people from Red Hat, and that is also the reason why I'm working with Paolo on this project as co-project leads. There are also other committers from Bosch and Red Hat, and here you can also see the link to the homepage. So if you have some time, take a look. So Paolo, can we go on? Okay. Yeah, so Eclipse Hono is an open source IoT connectivity solution, platform, if you will, and you can deploy it as a set of Docker images to arbitrary environments. As examples, you can use plain Docker Swarm, for example. That is what we, for example, use for running unit tests and integration tests on our development machines. You can deploy to Kubernetes and OpenShift. And that is actually what we do ourselves for running our commercial offering. We run it in a Kubernetes cluster, and the nice people at Red Hat, of course, deploy that to OpenShift usually, and that is what we also see later in the demo. So the goals of Eclipse Hono were overall, as Paolo also already pointed out, what the challenges and problems in the IoT are. We wanted to be able to interact with devices regardless of communication protocols. That in particular addresses the issue that there already exist many protocols that are established, that are in use. We do not want to ignore them and replace them by something new and fancy. Instead, we need to leverage all the devices that are in the field and be able to support them. We also want to support lots of devices, so we're talking about millions of devices. That is the scale that we want to address. For that matter, we do not want to trade in throughput for reliability, and that comes directly back to the two predominant communication patterns, meaning we need to be able to ideally or to optimize throughput for telemetry messages, but on the other hand, be also able to provide reliable delivery for command and control direction. And we do not intend to implement this based on the same technology, but be able to leverage one technology that is best suited for telemetry and another technology probably that is better suited for the other direction. So we do not want to simply implement another message broker, if you will, but instead we want to leverage technology that is specific to one of these directions. Then one of the other goals is to support arbitrary device protocols and integrate with existing infrastructure. That is in particular true for existing messaging infrastructure or messaging options that you want to employ. Are there any questions so far that we should address?
There is actually a question that might be coming too late, so feel free to defer to the end of the presentation. Pascal is wondering if you see, and maybe if open source has helped in bringing a convergence in terms of APIs for the cloud providers.
Not yet. That is something that would be great, of course. However, I think that open source can be a catalyst for such a development, meaning the more people rely on something like Eclipse Hono, they can establish a de facto standard, if you will, and that might be interesting for other cloud vendors to adopt then as well, providing compatibility with it. However, that has not happened yet, and as soon as we start having such influence on commercial offerings, I think then we have done a great job, but that is, I guess, some time away from now.
Well, and maybe to add on this, if we look back at something like Eclipse PAHO, the open source MQTT implementation from Eclipse, if you look at Amazon, IBM, Microsoft, and Azure, I mean, they all use PAHO as the sort of reference SDK client library for connecting and talking to their MQTT backends. So
that is true, but that's an implementation of an existing standard, of the MQTT standard that has been specified. That is the API that they implement. But if I understood the question correctly, it is about whether Hono will be able to actually provide a de facto standard API for interacting with devices. While that is exactly what our goal is, we are some time away from that. Okay, so the features that we currently have or will have, what we are really trying to establish is a set of uniform APIs for interacting with devices, and that is regardless of the communication protocol that the device actually uses. So from your applications in the back end, it should never be a difference whether the device actually is connected by means of MQTT, CoAP, or HTTP. So we provide out-of-the-box connectivity for devices for MQTT and HTTP by means of protocol adapters that we ship. But other protocols and totally proprietary protocols can be always implemented and added by implementing a custom protocol adapter. We will see that later, I guess. Then we have device-level authentication, meaning that all devices that connect to the platform need to properly authenticate. So currently we are supporting username password-based authentication for MQTT and HTTP, but we are also open for other authentication mechanisms, meaning we can add client-based authentication based on client certificates or token-based approaches, something like that. Then we have a tenant-based security model, meaning that that we enforce security and check authorizations at a tenant level. A tenant is basically a logical grouping or partitioning of the devices that you have in the system. And then you can say, this application is allowed to consume data from all devices that belong to tenant X or tenant Y, whatever. We support arbitrary messaging infrastructure as long as it is AMQP 1.0 based. We will come to that in a few slides to see how that works out or what that means. And then a very important aspect for us is to be able to scale out horizontally. And this is also reflected in the technology that we chose for deployment, meaning we provide a set of Docker images, and you can deploy them to any platform, container orchestration platform that is able then to, for example, scale up the instances of particular microservices that Hono consists of. And one very important feature is, and that is the reason why we chose to use AMQP 1.0 internally for the message exchange, is end-to-end flow control. And we will come to that later as well. I will give an example. Yeah, so the building blocks of Hono and the scope that it actually addresses is shown in this picture. On the left-hand side, we have the devices. On the right-hand side, we have the business applications. And in between, there is Hono and the AMQP messaging network. So the devices usually connect to an arbitrary communication protocol to a protocol adapter. Each protocol adapter is implemented to support a particular device communication protocol. We ship two out of the box, HTTP and MQTT. And then we have a component or several components, microservices for that matter, that implement the Hono API endpoints and are in particular responsible for enforcing security or supporting the enforcement of security. Then on the right-hand side, we have an AMQP messaging network. This is where the flexibility comes in. As long as it is AMQP 1.0, you can plug in everything you have basically there, and it can be used to forward the telemetry and events to the business applications and the other way around. End-to-end flow control here means that, can you go back? Yeah, end-to-end flow control here means that the whole system never accepts data or messages from devices if it is not able to process the data or send it downstream to a business application. And this is implemented by means of the features of AMQP 1.0, which provides a kind of back pressure mechanism, meaning the consumer of the data can always tell the sender how many messages it is able to process. And this credit counter is continually updated by the consumer or not. And if it is not increased, meaning the consumer does not give more credit to the sender, then the sender cannot send a message. And this builds up kind of a back pressure from the application at the downstream end to the devices at the upstream end. So the protocol adapters will at some time stop accepting messages from the devices and tell the devices, I cannot handle anymore. So this makes sure that the system is always in a stable state. But it also means that, for example, telemetry messages might be refused or discarded or dropped. But that is a sacrifice that we make in order to keep the system stable versus having the devices being able to publish all the data they want, but but sacrificing system stability for that matter. Okay. Any questions so far?
I think we're good with questions.
Okay. So then taking a look or going in one level deeper into the system, it looks something like this. So the protocol adapters interact with the microservices that Hono is made of by means of these set of APIs. The APIs are telemetry, event, device registration, credentials. The flow through the system is then from the devices on the left-hand side over the protocol adapter using the telemetry API to the Hono messaging service. Hono messaging forwards the data to, in this case, the Qubit dispatch router, which is our default demo implementation of the AMQP messaging network. And then the data is consumed by a business application. We will go to the APIs later after the demo in some more depth so that I can explain to you what the purpose of them is. So far, it is most important that you understand that telemetry and event are the important APIs for getting the data from the devices to the backend. And this is also the setup that we have for the demo. I think we come to that now. Can you go on? Yeah.
Yeah.
Okay, Paolo, why don't you take over from here?
Yeah, this is the deployment that I will show in a few seconds. So we will have Hono deployed on OpenShift using, as Kai already mentioned, the dispatch router and ActiveMQ Artemis as a broker for exchanging messages. And we will show something simple, just how we can connect using an HTTP and MQTT client for sending telemetry data to Hono, and then having such information got by a consumer application on the other side. So let me switch to the here I have the OpenShift console. OpenShift is a Kubernetes with more features in a simple way. So a more enterprise-grade version of Kubernetes with some feature on top of that. So a containers orchestrator. Here we can see some different services that are the components that Kai already mentioned in the previous slide. And other than that, we can see even the Grafana service that we use for showing metrics information from the system. So the message, the messaging throughputs on or something like that. The interesting thing about scaling, for example, is that using OpenShift and even Kubernetes, here we have, for example, only one instance running for this MQTT adapter, and we can just scale up and scale down for having more instances of this adapter for getting information and data from a huge number of devices. So scaling the instances when we have some change on the flow of data that we have from devices. So let me just jump to the console for showing how we can interact with the Hono. So I need to stop sharing and then share my console application window. You can see that, right?
Yeah, we can see that.
Okay. So in the upper windows, I will start a consumer application. So for example, I can just increase the font here. We are going to run a consumer application that we provide as an example from the Hono code base. We are connecting to OpenShift. In this case, OpenShift is running using the Minishift project. So we have OpenShift running in a virtual machine. And then we are providing a username and password for connecting to Hono in order to get data from there. So the application will start, and then with this example, we have just the receiver listening for telemetry data on the default tenant. So Kai has already mentioned what the tenant is. We are just using the default tenant, just one kind of grouping of the device that will start to send information there. Now, in Hono, we know we need that Hono needs to be aware of what are the devices that can send information. I already have registered and credentialed for one device. which is the device with the device ID 4711. So we can just use, for example, let me increase the font size. We can just use a simple application like Curve for simulating an HTTP device that is connecting to the HTTP adapter in this case, so providing information for the basic authentication, and then providing information in terms of a JSON payload, in this case, a sort of a temperature value with 5. We are connecting to the HTTP adapter on the telemetry stream. So if we send the message, we can see that okay, we can see that the message is sent to the HTTP adapter, is accepted by the HTTP adapter, and we can see that message coming from the consumer application in the upper windows. At the same time, for example, I can show that the HTTP REST adapter can provide more information to the client if, for example, we send data with the wrong password. For example, I'm using something like a wrong Hono secrets, and using the HTTP REST concept, the HTTP adapter just reply to the client that it is unauthorized for sending information. Or, for example, we have that the device needs to be enabled to be able to send information to data to Hono. For example, interacting with the registry, with the device registry that we have as an example in Hono, I can disable this device. So I am sending a JSON payload saying to Hono that I am disabling this device. After that, I can try to send information or data to Hono, and I shouldn't be able to do that because this device was disabled. So I have the HTTP reply as forbidden. So I'm not allowed to send information. Of course, I can re-enable the device to having it starting to send information. Using HTTP is just one of the out-of-the-box protocol that we are supporting with the Hono, with the HTTP adapter. On this side, for example, I can show how we can interact with the Hono using MQTT, but in this case, starting from scratch. So first of all, I need to register my device. So I need to provide information about my new device to the device registry. In this case, I'm registering a new device 4712. I like to say that in this JSON payload, we can add more information about the device. Some a sort of properties bag with more information like the manufacturer that are more related to the kind of application that we are developing and the kind of devices that we are using. So I'm going to register the device, and after that, I need to provide even credential information. As Kai said, we are supporting authentication using username and password. I have a credential JSON file where there is the hashed password because Hono doesn't need to know about what is the password, so in clear text. It just needs to know, in this case, what is the hash of the password that it will use for checking if the device is authorized or not for sending information. So after creating the credential and registering the device, I can just move to send information, in this case using the MQTT client. I'm using the Mosquito Publisher tool in this case. And with same information as the HTTP client, so username, password, and the channel I'm sending data, in this case the telemetry channel, I'm sending this message with the JSON payload. And I can see that the client will connect and then will publish data to the MQTT adapter. And on the upper side, we can see at the same time that the application on the consumer side is getting the message. Even in this case, just to show that we can handle errors from Hono related to interaction between device and Hono, even on HTTP and MQTT. I can just show if I'm going to use, for example, a wrong authorization ID in this case. Here I don't have something like the HTTP response code, but for example, I can see that after trying to connect to the adapter, the MQTT client receive a connect packet where the error related to the connect packet is not authorized. So we are using what we have, of course, in the MQTT protocol. Just to show, so this is just a simple example of how we can interact with the Hono from HTTP, from MQTT, having a consumer getting data from there. Just to show, for example, the information from the metrics dashboard, so from Grafana, I can start a simple script here that just sends some messages every 100 milliseconds. So connecting to the adapter, but seems to be some problem here. Okay.
Are you sure it's the right user and password?
Yeah.
I'm not sure, but or maybe you should remove the -D, the debugging. No.
No, I'm quite sure about the user because it's the device for the device for 711. I have just disabled such device.
Yeah, that is true.
Right?
That is true.
That's true. So we have to re-enable the device. We can do that here on this side. I can just re-enable my device. Okay, so it should just work now. Yeah. So the script is sending the information to Hono. Now I can stop sharing my console screen and just jump into the browser for showing that the Grafana metrics dashboard, I have to log into it. I have to switch to the main Hono dashboard. And here I can say that all the data are processed in real time, and this information are shown here. Something like the MQTT adapter information, REST adapter, the number of messaging that we have in system, and so on. So let me come back to the presentation.
So are there any questions regarding the demo?
Well, there's a question from Jörg that I think I will defer until later, if you don't mind, Jörg, and a question from someone else, which is actually along the lines of something I wanted to ask. You mentioned HTTP and MQTT. Do you have plans to integrate other protocols, and in particular things like lightweight M2M for device management?
So in particular, we are interested in integrating CoAP, of course, since I'm also working on Californium. We also want to provide an AMQP 1.0 protocol adapter so that devices can connect using AMQP 1.0, even though that is not as common today. Benjamin, I didn't really understand your question. Was that 1M to M? Or what was it?
Lightweight M2M?
Oh, lightweight M2M. Yeah, lightweight M2M itself is not a device communication protocol, but it's a management protocol on top of CoAP. So from my current understanding, or the way I would approach this today is have a CoAP protocol adapter and then have a lightweight M2M application as a business application downstream that is using Hono in order to interact with the device. But yeah, we do have an idea, or I really want to integrate that, but given that most telemetry use cases today are basically relying on MQTT or HTTP, or maybe plain CoAP, this is what we actually want to add first. But if you feel that that should be different, feel free to create an issue or drop us a line on the mailing list, and we can discuss that.
Kai, let me just add that in any case, you have the chance to add your own protocol adapter. So you can develop your protocol adapter for your custom protocol in an industrial environment, for example, or something that is proprietary. You can just implement as a new protocol adapter.
Absolutely. Yeah.
Right.
We also provide some abstract base classes that you can easily extend to get up and running very quickly.
So maybe one more question, actually, along the lines of device management. Jorg is wondering, in the microservice architecture, well, it seems Hono is taking care of like the telemetry control to some extent, the device registry as well. How does this all integrate with, say, device management?
That is a good question, and I guess I can touch on that when we talk about the device registration API.
All right, and maybe one last question then from Veronica. Paolo, maybe you can clarify in the demo, what did you use for the cloud, basically? Are you running on AWS?
Sorry, Benjamin, I didn't understand because I heard your voice a bit of...
Yeah,
Can you
apparently
repeat?
another...
It's something about what cloud I am using for that, right? Something like that?
In the demo.
Yeah, no, I'm not using any cloud infrastructure right now. I'm running OpenShift on my local PC. So using, in this specific case, Minishift, which is a project for running OpenShift as a virtual machine on my local laptop. So I'm using my laptop.
Okay, so how much time do we have left?
Say between 5 and 10 minutes. We took most, if not all, the questions.
Okay. So I guess so this is an overview of the APIs that Hono defines, specifies, and most of them also implements or requires from others to implement in order to work. So the telemetry and event APIs are obviously the most important ones because they define how device telemetry data and events is actually published and delivered to downstream consumers. All of these APIs are specified by means of AMQP1 message exchanges. You can find the specifications online on our website. If you go on, let's start with the telemetry and event API. It is, as I said, used to send data and events downstream. The telemetry part is using direct messaging, meaning the telemetry data is always directly routed to downstream consumers. There is no message broker involved, meaning also there is no persisting of these telemetry messages involved, meaning if a telemetry message gets lost on the way, it is gone. That is compared to the events, which are employing a store and forward mechanism, which is based on a message broker in our case in the demo setup. There we use Apache Artemis as a message broker. And the consumers always receive the data belonging from devices belonging to a particular tenant. We have seen that in the demo already. If you go on, this is used to illustrate the difference between routing telemetry data to a consumer versus brokering. So in the routing use case, as you can see, the router in the middle never really takes responsibility of the message. It just receives the message from the producer and routes it to a viable consumer. And the consumer then can indicate that it has accepted the message, and that acknowledgement is then again routed back to the producer. On the next slide, though, you see in a brokering environment for events, the producer sends a message to the broker, and the broker accepts the message, meaning it takes responsibility for the message. And usually, in our case at least, it will also persist the message in the local file system or a database or whatever. And then later on, a consumer can say, I'm interested in particular messages for a broker, for a tenant. And then the broker hands out the messages to the consumer, and the consumer can accept it. Okay, go on. During our development efforts, we very quickly realized that building a scalable AMQP messaging network, in particular with multiple brokers involved, is a thing that is not trivial and very hard to do, actually. You need a lot of expertise for that. And that is also the reason why this is not in scope of Hono itself. Instead, we are working very closely with the Unmask project. But Paolo, maybe you can tell us a little bit about that.
Yeah, Unmask is a project started by Red Hat here, and is a messaging as a service platform. So the main objective of Unmask is just providing you a messaging infrastructure, but just as a service. So you can just use a console for creating an address, something like a direct address that we use, for example, for telemetry, or you can just create a queue, a topic, and all the platform will take care for you about using the router for that, or creating a queue inside the broker, or creating a new instance of the broker, or something like that. So as a messaging as a service, so all managed for you. Of course, it provides the elastic scaling for handling a huge number of connections to the platform, supports all the communication patterns that we already saw before, and a lot of more features related to authentication, authorization, using, for example, the Keycloak project, and so on. You can find all the information here on the website.
Okay, go on. So now coming back to the question that we had heard before. So the device registration API is defined within Hono in order to make Hono aware of devices that can and will connect to the Hono services. However, the only really required operation of this API is the assert status operation, whereas the other operations for registering, deregistering, retrieving, or updating the information are optional. And that is because in most cases, we anticipate that in a real-world scenario, there will already be a system in place for managing device identities, or you might have your own provisioning process in place, how devices are manufactured or purchased and find their way into a system that you already have, where you manage the identities of the devices, or where you manage the type, whatever. And these systems often also provide an API for efficiently doing batch updates or bulk updates on these devices, enabling all devices of a tenant or whatever, stuff like that. And we did not really want to get too deep into how these APIs can look like, but instead we just wanted to make sure that you can always use this API and implement it as a lightweight facade on top of your existing system. And in fact, you only need to implement one particular operation, and that is the assert operation. And this is to show how Hono actually makes use of the device registration service and this particular operation. So when a device publishes data, for example, to the MQTT adapter, sends a message to the telemetry topic, then the MQTT adapter tries to get a registration assertion for the device. That means it sends a message to the device registration service indicating the tenant ID and the device ID. And in return, it wants a JSON web token asserting that the device is indeed registered for that tenant ID and that it is enabled. And if all of these two conditions are met, then the device registration service creates a JSON web token and signs it cryptographically and hands it back to the MQTT adapter. The MQTT adapter then uses this token and includes it in the message being published by the device and forwards it to the Hono messaging service, which then validates the token, which means it verifies the signature that the device registration service has created. And if that is all okay, it knows, okay, the device is really registered for that tenant and is also enabled, and it then forwards the message downstream. These assertions are usually cached by the adapters, by the MQTT adapter, for example. It is attached to the MQTT connection that we have with the client. So that not for each and every message we need to create this assertion again, but we only need to recreate it once the JSON Web Token has expired. So it usually has a lifetime of several minutes. Okay. So the credentials service is used to support the process of authenticating devices. Paolo has already demonstrated that in the demo by registering some credentials for a device, and also by means of showing that these credentials need to be presented by the devices when they connect, and that these credentials are actually verified. So we support, basically out of the box, we support hashed passwords, because that is what is mostly used when you have constrained devices. They usually have a username password on them. And then on connection establishment, you can have the device present these credentials to the protocol adapter. Again, there are different operations. The GET operation is the one that is mandatory because that is the one that is used by the protocol adapters. And the others are there for completeness, for reasons of completeness, so that in our demo implementation of the credential service, you can actually interact with the system in order to register the credentials as Paolo showed. However, if you already have a system in place that does this, again, you can just implement a lightweight facade on top of that for the GET operation. So when a device connects, in this case, an MQTT device connects to the MQTT adapter, sends its connect message with the username and password in it. Then the MQTT adapter extracts the tenant and the authentication ID from the username and sends it to the credential service in order to get the credentials that are registered for it. So in this case, it gets the credentials, the hashed password credentials for the user, for the sensor that is authenticating. It gets back the credentials from the credential service, and then it can use the information in there. In this case, this is really the hashed password, and it can create the hash of the password that the device provided and match it and verify the credentials. So the credential service is always there to only store the secrets, if you will, for doing the credentials verification, but the verification itself is always the responsibility of the protocol adapters. Are there any questions? I guess we're running out of time, so I would rather answer more questions instead of going through more of the stuff, because I guess we covered basically the most important stuff.
All right. Well, yeah, I mean, and you will make the slides available, right? We can add the link in YouTube and on Meetup. Yes, there's a bunch of questions. Maybe something for Paolo, and just to clarify, Pascal is wondering if auto scaling is built in. You mentioned elastic scaling, especially with Unmask. Is this something like, is this done actually automatically, or?
Yes, there are some features that we are implementing to have auto scaling, for example, in Unmask. So checking some metrics that will be able to spin up your new instances of the service that you need, or scale down when these metrics values goes down, for example.
So for Hono, the same mechanism basically applies. We have not built it in simply because we make no particular assumption regarding the deployment target that you deploy to. However, Hono provides metrics that you can track and use as the criteria for actually scaling up or scaling down. So we have, for example, a metric regarding the overall number of messages being processed, or the number of messages being discarded, often because of a lack of computing resources. So once that metric increases, you could take that as an indicator that you need to scale up. But doing the scaling up, you will need to implement that by means of your container orchestration system. So in Kubernetes, you will need to use the Kubernetes API, for example, or auto scaling features of Kubernetes to scale up the pods that constitute Hono in this case.
Mm-hmm. Okay. Back maybe on your presentation regarding your part on how the connection of MQTT endpoints work. Jorg is wondering if the best way to qualify it is to basically say that Hono emulates an MQTT broker.
Yes, that is absolutely true. We did not mention that. Hono by no means is an MQTT broker, but we only support the MQTT protocol to publish messages. So a device can connect to Hono's protocol adapter, use it following the MQTT protocol for a connection establishment, and can then use a publish. I think it's publish, right, Paulo? In a publish message,
right.
use a publish frame, or I don't know how it's called, a packet, I guess, a publish packet, in order to transfer the data. But by no means is Hono a full-fledged MQTT broker.
All right, makes sense.
So it means that you can't subscribe, for example, on the MQTT side for receiving messages, but the consumer or business application have to connect using AQP.
Yeah.
Okay. So Jorg is actually happy that he was spot on with the question. At least another question, and for people watching, if you have last minute questions, now is your chance. So yeah, the last question, at least that I see right now, would be from Philippe. I think both you, Kai, and Paolo are somewhat involved with Eclipse Kapua. Does the message routing in Kapua rely on Hono?
As far as I know, it does not.
No.
The message routing in Kapua is based on
the ActiveMQ broker.
I thought it was Apache Camel.
It used Camel, but using the ActiveMQ broker as a messaging infrastructure for that.
Yeah, as the broker infrastructure for that is true. Yeah. However, there are plans to integrate Hono into Kapua and use it as the data ingestion or connectivity layer for connecting devices. Once the Kapua guys have finished their job of splitting up the system into a microservice architecture. And in fact, we have 2 committers on Hono who are actually also committers on Kapua. I guess that is Henrik and Dejan, right, Paulo?
Yeah, Dejan.
Yeah.
Actually, that probably brings us to a question from Mike, and maybe Kai, you have Kai and Paolo in your slide deck at the very end. Mike is wondering what's a recommended read or like document or anything for basically doing a deep dive into Hono. To some extent, I guess this also applies to a project like Kapua. So what's the best way for people to, 1, get involved, and 2, learn more about Hono?
Well, in case of Hono, it is all that we have is on the website. So the Hono homepage contains kind of a lot of documentation for the APIs. We have some guides regarding deployment, regarding the architecture, basic concepts of identity and stuff. So reading through all of that material should give you a pretty good start. And then the best way to get in touch is either by joining the chat that we are on. There's also a link on the website for that. Joining the mailing list, or creating issues on GitHub. That is where a lot of discussions happen regarding how a feature should be implemented. What are the pros and cons? So a lot of the architectural discussions are actually done in pull requests on GitHub. So that, from my point of view, should be the best way to get into it.
Okay, well, I think we need to wrap up. There is one very last question from Martine. She's actually wondering if there is any plan to add support for medical devices by means of what appears to be an IEEE protocol 11073. So I guess I will reformulate the question. Is the Eclipse Hono team interested in sort of hosting and maintaining a set of protocol adapters, or would you rather encourage the community to come up with their own sort of third-party plugins, and you guys would just be promoting them? Or
so I guess it is a mixture of both approaches. I think we are interested in hosting protocol or including protocol adapters for common protocols that are very widespread and for which we also are able to provide support, meaning we know the code, we know the protocol, or at least we have a committer in the project who feels kind of responsible for this code. If that is not possible or not the case, or if we do not find a committer or can recruit a new committer that is actually developing that code, then I guess it would be better to implement such a protocol adapter in a separate project, and we can then endorse and promote it and tell people, well, this is compatible with Hono, and list it on our website. So these are protocol adapters that you can use with it. I get that. That would be a better approach then.
Yeah, that makes sense. So, Martin, if you're interested in like pursuing with possibly having support for this protocol, I guess back to Kai's point, get in touch with the team on the chat or on the mailing list to get maybe advice on how best to do it, how to best get started. This has to be the longest virtual IoT meetup ever, but lots of people have been staying until the end, so that's great. Thanks again to Kai and Paolo for the great presentation and demo as well. If people watching this not live and watching the replay, you can still ask questions on the YouTube comments, and we'll make sure to let Kai and Paolo know so that they can answer those. Feel free to reach out on the mailing list as well, of course. Some general announcements, as always. Please provide feedback on meetup.com as to topics that you would like to see covered. Feel free to review the group as well. And so, yeah, 3 things basically. We launched a new Eclipse IoT newsletter. The first edition went out actually just today. So we'll be posting the link in the comments and on Meetup shortly. Please subscribe if you haven't already. That's going to be a great resource, and we're looking at doing this every other month, at least, or every quarter at a minimum. If you have articles that you're interested in contributing, please let us know. So there's that. The IoT Challenge. You might be familiar with the Open IoT Challenge. The 4th edition is on its way. We are collecting applications until November the 13th. There's great prizes, including for proposals. Like even if you just have a cool idea and you may require some help in terms of hardware, we have prizes for that. So the best proposals get awarded. And last but not least, for those of you guys in Europe, I guess there was a lot of people from Americas today. But if you're in Europe and or if you're going to be around Stuttgart end of this month, please remember that the Eclipse IoT community is meeting up for all things IoT. So a smart home day, an Eclipse IoT day. Kai will be there. Paolo, I don't know about you. Will you be there?
No, I don't think so.
Lots of other Red Hat.
I apologize for that. I apologize. But yes, there are a lot of folks from my team.
Yeah, the name of Dejan came up. Dejan is very active on Hono Kapua. He will be there. We're going to have a hackathon around the Eclipse IoT testbeds. And like even if you're not that familiar with Eclipse, just do IoT in general, want to talk about and learn about what's being done by companies like Bosch, Red Hat, and many others. Join us. Any questions, just let us know. Like if you want more details, but just eclipsecon.org should be where you have a look. That was a really great meetup, actually. Like I hope you guys enjoyed it. It looks like you did. Looking at the chat, great discussions there. We'll be back. I should know in a few weeks. I'm pretty sure the next meetup is going to be around hardware. That's going to be the Mango platform from the open source and open hardware platform from Sierra Wireless. They're going to be presenting their what they're doing, and like that's some really cool open source projects there. Other topics you would like to see covered, let us know. So yeah, that's it. Thanks again, Kai, Paolo. Enjoy your evening or enjoy your day, depending on where you are.
Yeah, thanks for the opportunity, Benjamin, for letting us showing off with Hono. Thanks again.
Pleasure having you guys.
Yes, thank you very much.
See you soon. Bye.
Bye.
Bye.